Hello! In this video I am turning my control panel with touchscreen display into a personal AI assistant, one that doesn't need the internet and runs entirely within my home network. Let me explain how. Some time ago I built my own local AI server. It runs completely offline, no connection to the internet required, and it responds to the questions just like ChatGPT. I can access it from any device at my home, from phone, laptop or even my TV, or through a simple local website. Best part, it costs me absolutely nothing. The whole system is open sourced and I'm using only my old laptop as a server. If you're curious how I set that up, I already made a video about it and you can check that out later. Link in the description. Now, back to today's project. With the control panel, I'm going to connect it to my Wi-Fi, send question to my local AI server using its API and display the AI answer right on the screen. This is just stage 1 of the project. In this first part, I will focus on connecting the control panel to the Wi-Fi, making single request to the AI server, writing the response and display the result on the screen. And later on I want to go even further. In the next stage I will add a basic user interface, voice input using speech to text and maybe even text to speech output. Basically, I want to create a real, fully functional AI assistant that lives on my desk, completely offline. But let's not get ahead of ourselves. For now, it's all about building the connection Wi-Fi AI server screen output. What's great about the control panel is that it's fully self-contained. There is no need for an Arduino, Raspberry Pi or any extra module. It has everything built in. ESP32 S3 chip, touchscreen, Wi-Fi and display all in one. So here's how I'm doing it. First I plug it into my computer via USB, open an Arduino IDE and upload the code. Once that's done, I can disconnect and even run it off a power bank to test if it works completely on its own. Once I confirm it's running, I will go over the code and explain how it works. I'll be honest, it took a while to get it all working. I went through a lot of code versions, testing step by step until it's finally come together. By the way, if you want to follow along, I already made a separate video showing how to set up Arduino IDE for the control panel. Check that out if you need help getting started. Along the way I also built some fun side projects with this panel, like a digital photo frame and a drawing pad that sends you a sketch directly to your PC. If you are interested, some of this you can find in my previous videos. But back to my project. First, we see a welcome message saying the screen has booted up and now the Wi-Fi connection is in progress. Connected. Now I automatically send a query to my local AI server and see a slightly different response each time. And that's basically it. The connection between my panel and the AI server is working on my Wi-Fi network. The panel displays the response, as you can see, each time different. And when it starts to get bored, it sends a query to the AI server and displays jokes. It also checks to see if it's already sent me a similar joke. The jokes aren't very good, so we have some space to improving. If you are interested in the code, I will probably share it on my blog soon. So if you are interested, you can check it out. In the meantime, I quickly go through the specific blocks and explain what's going on. Every Arduino sketch follows a clear structure. At the top we have our includes, which are like importing toolkit for specific functionalities. Below that we define global variables and helper functions that can be used throughout our program. The core of this program lies in two main functions. The setup functions, which runs just once when you ESP32 power on. It handles all the initial configuration. And the loop function, which runs repeatedly and continuously, managing our assistant's ongoing tasks and interactions. Okay, let's visualize this structure in our code. Section 1 includes global definitions. At the very beginning we include essential libraries like Wi-Fi for network connectivity, HTTP client for making web requests, and Lovian GFX for all our display graphics. We then define our UI colors to give our interface a consistent look. Notice how user text color is set to green for your questions and AI text color is blue for the AI assistant replies. We also define various text sizes to control the font size of different elements of the screen, like chat text size for regular messages and joke text size, more permanent joke display. You also find placeholder for your Wi-Fi credentials, SSID and password. Make sure to replace this with your actual network name and password. Crucially, we define invoke URL, which points to our local AI server. For this project, I am running Ollama on my computer, which I started simply by typing Ollama serve in the terminal. To ensure I know exactly what kind of response to expect and how to extract the joke, I first test my AI server curl command like this. And this allowed me to see the full JSON response, confirming that the server was working and showing me precisely which part of the response contained the actual AI generated text. This knowledge is vital for our code to correctly parse the jokes. Finally, we have variables for our joke future, like last joke time to track the interval, joke interval ms set to 1 minute, and joke history to store the last few jokes. Section 2 helper functions. This our utility function that performs specific reusable tasks. Send I2C command is a simple function that sends commands over the I2C bus to the crowd panel's I/O expander, which is responsible for controlling the display backlight. Reset GT911 performs a hardware reset to the GT911 touch controller. This is a standard procedure to ensure the touch functionality initializes correctly. Okay, the display chat message function is the core of the user interface. In short, it's a smart driving tool that displayed a chat message on the screen. Here is a breakdown of what it does. Picks the right color and position. It checks if the message is from the user or from the AI assistant. If it's from the user, it uses green text and align it to the right. If it's from the AI, it uses blue text and align it to the left. It also handles log messages. It automatically calculates how to wrap text so that long sentences fit nicely on the screen without running off the edge. And of course, it draws the message. It first clears the area where the message will go, then draw the sender's icon, like you or AI assistant, and finally the message text itself in the correct color and size. Display status message is a simpler function. It's used for displaying centered status message, like connecting to Wi-Fi or AI assistant is thinking. Section 3. The setup function runs once. Okay, the setup function is where our ESP32 comes to life. It starts by initializing serial communication for debugging messages, then set up the I2C bus and activates the display's backlight. After a quick reset of the touch controller, it initializes the Lovian GFX display library and clears the screen to black. We then display a series of initial messages: hello, connecting to Wi-Fi, and connected to Wi-Fi, providing clear feedback during the startup process. Following that, a personalized welcome sequence is displayed, telling you the system are online and ready. Then we have some funny text messages, and then comes our initial AI interaction block. If Wi-Fi is connected, the screen is cleared. Question why the sky is blue is displayed at the fixed position near to the top right. While the AI processes, our AI assistant is thinking. Message appears. After fetching the AI response from our local server, the screen is cleared again. Your question is then redrawn, and the AI answer is then displayed just below. This creates a clear, stable conversation flow. If there is an error during the AI request or parsing an appropriate message is displayed. Finally, the screen is cleared one last time, and the assistant displays "How can I help you?" entering its idle state ready for your commands. Section 4. The loop function runs continuously. The loop function is where our assistant's continuously operation resides. It's to periodically tell you a joke. It continuously checks if 1 minute has passed since the last joke was told. When the time is right, it will display message like "Hey boss, I'm a bit bored," and fetching a joke. It then makes a HTTP request to our local AI server for a new joke. To ensure variety, it checks its joke history to avoid repeating jokes that were recently told. Retrying a few times if it gets a duplicate. Once a unique joke is found, it displays "Do you know this joke?" followed by the joke itself using a slightly larger font size to make it stand out. After a set duration, the screen cleared and the assistant returning to its "How can I help you?" it will state, waiting for the next joke interval or your interaction. If for any reason it can't fetch a unique joke, it will display an error message before returning to idle. The delay 1000 at the end of the loop ensures that ESP32 doesn't run too fast, but the "How can I help you?" message remains on the screen until the next joke cycle begins. And that's a comprehensive look at the code powering your Crowd Panel AI assistant. This setup provides a stable, visually appealing and interactive experience. Feel free to experiment with the code, modify the message or even add new features to make your assistant even more personal. Okay, that's all for today. If you enjoyed this video, smash the like button and subscribe to my channel so you don't miss new content. Thanks for watching and see you in the next video.